Alright, so today we're going to be learning about section 2.3 and solving quadratic equations. Once again, comes with the notice that there are people in my house who make a lot of noise, like my children. You may hear them. I apologize. If you have any questions, please email or call me. And we'll be talking about learning 4 methods to solve quadratic equations, factoring, square root property, completing the square, and quadratic formula. When you take this course, I'm assuming you've had some exposure to all of them, especially concentrating on knowing how to factor. We'll review factoring, but in later lessons, while I would be pointing out how I factor things, I will assume that you can follow along. If you cannot, please contact me. We can go over factoring again. Like I tell my students, there's one thing you should remember from college algebra besides, everything really. Factoring would be to one of those things that will stand out the most if you miss it now, if you don't understand what's going on now. A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0, because if it was, it would be a linear equation. This is called standard form of a quadratic equation. We have everything on the left-hand side. We have an ax squared term. We may not have a bx term. That may be 0. But if we do, it's listed here. And then a constant if we have one. So factoring. Hopefully everybody's been exposed to factoring by now. If we haven't, there are other videos I can do on it. I can make a video if you need me to on it separately. But this method works well if the quadratic equation yet. This method works well if the quadratic expression can be factored easily. To solve by factoring, we use the zero factor property. If the property of two algebraic expressions is 0, then at least one of the factors is equal to 0. In other words, if a times b equals 0, then a equals 0 or b equals 0. Because the only way you're going to get 0 out for our algebra system that we're living in, and other algebra systems, interesting things can happen. But for us, if I want this to be 0, one of these numbers had to be 0. I can't take two non-zero numbers, multiply them together, and get 0 back out. Note, we have to require the equation to be equal to 0 for this to happen. How to solve by factoring. We write the equation in standard form. We factor, set each factor equal to 0, solve for the equations from step 3, check the solutions in the original equation. Checking usually comes very useful in a lot of quadratic equations. If you're really good with your calculator skills, it can make that part really quick. So here we have a basic equation to factor. So what we need to do is we need to find factors of 12 that will give a sum or difference of 8. So looking at this, we set up our parentheses. Once again, I expect you have some exposure to this. If you have no idea what I'm talking about, I can make other videos on that, going that in detail. So the only way to get x, because basically in order to get this, what do? We FOILed first, outer, inner, last. So I'm looking for the first terms I would have gotten to multiply to give me x squared. Well, there's only one way of x squared factors, and that's x times x will give me x squared. My outer terms and my inner terms will combine. So this will be my I and my O terms added together. So let's look at the last term. The last term is 12. So I need to figure out what factors of 12 can add or subtract to give me 8. Here this is positive, so this right here, this positive, means they have the same sign. Plus sign means same sign. So they're both going to be negative, both going to be positive. Since 8 is negative, that means they're both negative. So I'm going to look for factors of 12, so let me list all those out. So I have 1 times 12, 2 times 6, and then 3 times 4. And so they're both going to be negative, so basically I'm looking for a sum of two negative numbers that'll give me 8. So just real quick, if I were to add these two together, I'd get 13, this would be 8, and this would be 7. So looking at this, I want the 8. Now, notice I said adding, and we want this to be negative. It just means that this 2 is negative and that 6 was negative. So it'd be minus 2, minus 6. And we're essentially done. We factored it. It wants us to solve, so we have to set each factor equal to 0. So we have x minus 2 equals 0 and x minus 6 equals 0 now. Those are our two factors. And then we're just going to say this is x equals 2 and x equals 6. And those are our solutions. And we can check them. We can plug them back in. For example, if you wanted to plug 2 in, you get 2 squared minus 8 times 2 plus 12. So that'd be 4 minus 16 plus 12. That equals 0. That checks out. And you can do the same thing for 6. 6 squared minus 8 times 6 plus 12. That would give you 36 minus 48 plus 12 is 0. That checks out as well. So going back to stuff you've learned about factoring, remember we're undoing FOIL. You're going to get the first term and the last term. That'll give you your hints to make the middle term. When this leading coefficient is 1, that's really, really quick because all you're looking at for the factors of the last term to give you your middle term here. Now here's one that's a little bit more interesting because our leading term is not 1. So looking at this, I'm going to go off to the side somewhere, let's say right here. I'm going to say, what are my factors of 3, which are going to be 1 and 3, factors of 30, which would be 1 and 30. Excuse me. 2 and 15, 3 and 10, and then 5 and 6. And after that, I repeat myself. So those are all my factors. Oh no, this is not 30, this is 20. I'm thinking of a different one. I would edit this out if I had my editing software with me, and I don't. And 4 and 5. Those are the only ways I get 20 back out. So I need a combination of the factors of 20 and the factors of 3 that give me 7. So my first, outer, inner, last. So there's only one way to factor 3y squared, and that's going to be, so I'm going to write my parentheses, 3y times y. That's the only way I can factor that. If I had multiple ways to factor this first one, I couldn't write this first step down yet. So I'm going to have something times 3 and something times 1. And this is going to be right here, the negative means the difference. So this is going to be a different sign. So they're going to have opposing signs. So basically I'm looking for the difference of these two things to give me my outer, my inner term to give me my middle term here. So I'm going to take the factors of 20, I'm going to line these up until I get 7. The difference of them. So let's say if I had 3 times 20 and 1, well that'll give me 60 and 1, and the difference of 60 and 1 is 61, oh not 61, excuse me, 59. That's nowhere close to 7. I'm going to have to get another sheet of paper here to do this. And so let's say I have 30 times, I don't know, what was one of them? 4 and, is that what I want? No, I want to do 30 times 5, or 3 times 5, why did I say 30? 3 times 5 and 1 times 4. And so we're going to take this is going to be 15, and this is going to be 4. I take their difference, and that's going to be 11. I don't care whether it's positive or negative right now. I'm just trying to get the same number here, whether it's negative or positive. That doesn't work. But it looks close. So if we try 3 times 4 and 1 times 5, we're going to get 12 and 5, and the difference of 12 and 5 is 7. 7 needs to be positive here, so I'm going to make the 12 positive and the 5 negative. So in other words, I'm going to write here, I need this 3 times a 4, so that means I need 3y times 4, so it's going to be here with this y, and it needs to be positive. And then I need a y, this is essentially y here, y. I need 1y times 5, negative 5. So this gives me a negative 5 right here. And that's the guess and check method, or the mix and match, maybe called different things. They changed It's always amazing. Every few years in all the math books, they change all the terminology, but the math stays the same. It stayed the same for hundreds, if in some cases, thousands of years. But they like to call it different things so they can write new books. So we have 3y equals 5. Move the 5 to the other side. Divide both sides by 3. I'm going to get y equals 5 over 3, or y equals -4. Those are our two answers. Now, there is another way of doing this. Take another sheet out. And that is the AC method. And you'll see it referenced in Hawks. Assuming I can spell. If you were in class in my lectures, you know that I can't spell. I can do math. I can't spell. A lot in life. Anyway, so you basically say you have 3y squared plus 7 minus 20. And you take the 3 and the 20 and multiply it together and get 60. So basically you find the factors of 60. If this method confuses you, just fast forward. The factors of 60, like 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. And then we have, what else do we have? 6 and 10. And then we have, is that everything? I feel like I'm missing something. Who am I missing? Nope, I think that's it. 8 doesn't divide into it. 7 doesn't divide into it. 9 doesn't divide into it. And then we're at 10 again. So we go through here and we're looking for the difference. So we take the difference of all these real quick. So the difference, so pretend like these are all subtractions. So you get 59. And I don't really care about the sign, just the difference of these two numbers. 28. This would be 17. This would be 11. This would be 7. And this would be 4. And we want the 7. And we want the 5 to be negative, and the 12 to be positive to give us 7. And so we break this 7y up into -5y plus 12y, and then we'd factor by grouping, and so we'd have 3y squared. More on that later. I'm just showing, some students may see this and be like, couldn't you do it this way? It would have been so much easier. Yeah, for certain numbers. For other numbers, not so much. And then you factor out a y here. And then from these two, you'd factor out a 4, excuse me. Once again, if this does not help, you don't have to learn it this way. We factor 3y minus 5 out from both of these, and we get the same factors we got before. So that's the AC method. If you want to know more or see more work like that, there's there's a section in your Hawks instructional method that'll show it to you. Also, I'll be happy to make more videos about it if you'd like. There are plenty of videos on the internet on how to do the factoring method, mix and match. They're all basically some version of the AC method and some versions of smart guess and check. You know, you make really good guesses off to begin with. There are some interesting methods that aren't technically correct math, and if you want me to look at one of those and see if it's logically correct, send me a video or a detailed explanation on a sheet of paper about how you factor. I'll take a look over it, and as long as it works and it's mathematically sound, you can use it. But if you're not sure, send it to me. So we have other factoring techniques. Factoring out the greatest common factor, GCF, always do this first. So one thing we might want to try here is make sure we couldn't factor out a 3 first before we did this. Oh, is it doing that focusing thing? 3 first, if that worked, great. Everything divisible by 3. In this case, that wasn't the case. Factor by trial and error, usually easy if the leading coefficient is 1. It's always easier when the leading coefficient is 1. Factor by the AC method works on every factorable quadratic. Unfortunately, sometimes this number may have hundreds of pairs of factors. 60's got a lot to begin with, but if you had something like 528, you know, that might have been a huge amount of factors. 516. You know, that has a huge number of factors. You might not be able to factor that in any reasonable amount of time. Factor by recognizing special products or perfect squares or difference of squares. So basically it's talking about when you have a squared minus b squared, and we showed this with conjugates in the other lecture. You have a minus b times a plus b. And so that would be the different squares, perfect squares, where you get a squared, or sorry, not a minus b quantity squared or plus, and you'd get a squared plus 2ab plus b squared. If you recognize that it's one of these, it follows this pattern or this pattern, then you're looking at one of those special products. And really, to tell you the truth, there are only so many quadratic equations with factors or leading coefficients less than 20 or 30 that factor. You can pretty much, if you spend, I don't know, a couple hours, you can pretty much generate most of the basic ones, and you can see a pattern. I'm not saying you have to memorize them all. I'm just saying it becomes pretty clear. Now, when they're higher numbers and their coefficients get over 30, 40, you're going to have to sit down and crunch some numbers later on. The second method is square root property. This method only works if one side of the equation is a perfect square and the other is a number. To solve this equation, we use the square root property. In other words, if x squared equals c, then x equals the square root of c, or x equals negative square root of c. This is commonly abbreviated as x equals plus or minus the square root of c. So in other words, we just take the square root of both sides to solve for x. This works best if we don't have a b term, or if we have a perfect square on one side to begin with, constant on the other. So let's do that. Let's say this is x squared equals 19. So that means it's going to be x equals plus or minus the square root of 19. If there's simplify, if there is a perfect square. Perfect square. Inside. And here 19 is prime numbers, so we don't need to simplify that. Inside is a factor. You'll read that. Next one is not as quick, but we have this perfect square if we got rid of this negative 5 on both sides by dividing by negative 5. So we get x plus 8 squared. I'm going to do the plus or minus. Equals 100. So I take the square root of both sides, and that's going to give me x plus 8 equals plus or minus. Square root of 100 is 10. Sometimes it's a good idea to note that you need to put that plus or minus as soon as you take the square root so you don't forget it. If you put it in the next step, that's fine as well, as long as it shows up somewhere. And then we have x equals negative 8 plus or minus 10. And you can't put this answer into Hawks. It won't take it, nor will it take the plus or minus there. What it wants you to do is say we have negative 8 plus 10, which is 2, and negative 8 minus 10, which is negative 18. And we're done. If you need to write it in two separate ones, you can do that as well before you do the math. It's the same answer. Now note, this method can generate imaginary numbers. You can get imaginary numbers. For example, this would be a separate example. Example exercise, maybe 4.1. If you had something like x squared plus, let's say 4 equals 0, well, that'd be x squared equals negative 4. So x equals plus or minus the square root of negative 4, which would be plus or minus I. 2, actually we would write it as, I don't know why I wrote the square root there. That will equal plus or minus 2i. So if you get negatives underneath that square root, you need to bring them out as i's. Even square root. Completing the square. So this is how we get the quadratic formula, and this always works. It's just not super useful in a lot of situations because you get fractions back out. This method can be used for any quadratic equation. It's easiest to use when the leading coefficient of x squared is 1. Also, if b is even, it works good. Otherwise, you're going to get fractions back out. How to use this method with fractions is fine. Fractions are your friend. How to use this method to make sure that the coefficient of, need to start by making sure the coefficient of x squared is 1. If it's not, I would factor normally or use the quadratic formula. Move the constant term to the other side. Add half the middle term squared, b over 2 squared, to both sides of the equation. Solve by using the square root property. Note completing the square is also necessary for graphing circles. And 2.6, it's also necessary to put parabolas in vertex form as well. So this looks exactly like the problem we had before when we started, except this was, and we go back, way back, we go back here, focus, thank you. We notice the sign here was negative and this was plus. That factored. Here, if we try to do that and we say, oh, well, all I need to do is take factors of 12. That'd be 1 and 12. That'd be 2 and 6. And then that would be 3 and 4. And I'm looking for a difference. And if we look for a difference, well, that would be what? 11 or 4 or 1. None of those is 8. Okay? So I can't get the difference of the factors of 12 to give me positive 8. That's not going to happen. So in other words, it's going to have a radical in it. It's going to have an imaginary number in it. It's not going to factor nicely. So if this leading coefficient is 1, I take b, which equals 8. And so that means half of b squared is going to be 4 squared, which is 16. So what I'm going to do here is, I'm going to leave that alone for a second. I got ahead of myself. I'm going to write this as x squared plus 8x plus something equals, and I'm going to move this 12 to the other side, positive 12 plus that same something. I want to have both sides be even. So if I'm going to add to the left side, I'm going to add to the right side. And here we found out, what are we going to add? Half of the middle term squared, which is going to be 16. So I'm going to do 16 here, 16 there. And so now, why did I do that? I made this side a perfect square. So now this factors. What are two factors of 16 that add to give me 8? Because we're looking for the sum, because it's positive. And that's going to be the factors of x plus 4 times x plus 4. Factors nicely. And this over here is going to be 28. So actually we'd write this as x plus 4 quantity squared equals 28. And then I take the square root of both sides. So that's going to be x plus 4 equals plus or minus the square root of 28. And then I'm going to have x equals negative 4 plus or minus the square root of 28. So this square root of 28, we need to simplify. And so simplify would be what? That would be the square root of 7 times 4. 4 is a perfect square, so that would be that we'd get 2 times the square root of 7. And so now we have x equals negative 4 plus or minus 2 square root of 7. I can't combine these in any meaningful way, but once you write your answers in Hawks, they'll want it as negative 4 plus 2 square root of 7, comma, negative 4 minus 2 square root of 7. And that would be your answer. So I mean, I've done all my work correctly. If I don't, y'all let me know. And so once again, why do we do this? We made this side a perfect square, so we can take the square root of both sides. And you can add the same number to both sides, is why we're allowed to do this, and make that perfect square. And if you were to do this with the generic, and this is A, this is B, and this is C, you would generate the quadratic formula. And it's something I can show. It's plenty of stuff online. You can find plenty of people deriving this formula from the standard form and seeing how it's done. But for us, it's a little bit beyond today's lesson, but it can be done. It is done. So let's look over this. Method 4 for quadratic formulas is we have this method works for any quadratic equation. Remember that the standard form of quadratic equation is ax squared plus bx plus c equals 0. The quadratic formula is as follows, where we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is a formula you have to know for basically most of your math classes here on out. You're allowed a sheet of notes, so you can put this as one of your formula on your notes when you're taking an exam. In my class. For some other's class, somebody watching this, it's not for my class, that may be different. All right, so let's write our formula up here so we have it to reference. X equals negative b plus or minus b squared minus 4ac all over 2a. And here we have a is equal to 6. B is equal to 12. And, oh, it's not in standard form, so we can't do that yet. So let's put it in standard form first. So that'd be 6y squared. And then I subtract 10y from both sides. So that's going to be plus 2y minus 5. Now I have it in standard form. Now I can say that a is equal to 6, b is equal to 2, and c is equal to negative 5. So looking at this, I'm going to have x equals, and first always try to see if it factors nicely. Are there factors of 6 and 5 that can give me 2? No, because everything 5 times anything will give you something bigger than 2, even though it's a difference. There's nothing that really does that. And you can go through the different combinations if you like. Basically, you're looking for the difference of the factors of 30 that have a difference of 2, and that's not going to happen. So looking at this, we have x equals, so we have b, which is 2, so we're going to have negative 2 plus or minus the square root of 2 squared minus 4 times a times c all over 2 times a. And so that's going to give us negative 2 plus or minus square root of 4. That's 2 squared. Remember, put that in parentheses because if it was a negative 2, that would still make this positive. 4 minus 4 times negative. Negative 4 times negative 5 is 20. 20 times 6, so 20 times 6. And that's going to be 120. Positive 120. All over 12. So you're going to get x equals negative 2 plus or minus, and the square root of 124 all over 12. That simplifies to, we can factor out a 4 from that, so we get 12. We factor out a 4, so that's going to be 3. It's going to be 1, it'll be 31. So that becomes a 2 times 31, because that's going to be 4 times 31. Take the square root of that, and that's going to be 2 square root of 31. This is me doing division right here. This is me factoring out and simplifying right here. All over 12. I can take a 2 out of that numerator, and so that can be 2 times negative 1 plus or minus square root of 31 all over 2 times 6. I cancel my 2's, and now I have 1, negative 1 plus or minus 31 all over 6, and that's my answer. And once again, you write it as 2 separate ones, one where it's positive, one where it's negative. And since we've been getting so many non-imaginary answers back out, we could do this one again. And this time, we'll change this to a positive 5 so you can see what happens when you get imaginary numbers. So that'd be plus 2y plus 5 equals 0. Standard form, we have a is equal to 6, b is equal to 2, and c is now equal to positive 5. So that's going to give us x equals negative 2 plus or minus the square root of, and essentially that's going to be 2 squared minus 4 times a times c all over 2 times 6. That's going to give me negative 2 plus or minus 4. And this is going to be minus 120 now. This is going to be over 2 times 6, or actually 12 now. It's going to be x equals negative 2 plus or minus the square root of negative 116 all over 12. Can we divide, I'm going to say we can divide 4 into that. I'm not worried about it being negative right now. So that goes in there 2 times, that's an 8, carry down to 3, and it's going to be 6, and then that's going to go in 9 times, so it's 29. So we're going to have 4 times 29, and we take the square root of that, and that's going to be 2 times the square root of 29. And once again, this is negative 29. And so what we get here is we're going to get 2 factored out, and we have that negative 29 on the inside. We can't leave that as negative 29. That's going to be an imaginary number. 2i square root of 29 over 12. Factor out a 2 once again from the numerator. Twos cancel. And our final answer is going to be 1 plus or minus I square root of 29 all over 6. Once again, you have to write that down 2 times. One in the positive version, one in the negative version in your homework. So this should hopefully be a review. Past this point, I'm assuming that you all can follow along. You know what factoring is. You know what completing the square is. Doing your homework. This is a section where I often tell students to do the homework multiple times. In Hawks, if that's what you're using for my class, you can recertify as many times as you want. You can make your own practice test over sections that you pick. And so if you're having a lot of trouble with factoring, go through practice multiple times, go through certify multiple times. You can't uncertify yourself once you're certified. Or make practice tests with just this section, or maybe this section is from chapter 2 from 2.3 on to 2.45, and just do them there. And so, you know, you just have a good handle on how to get these done. And yeah. So if y'all have any questions, let me know. Y'all have a great day. Thanks.